Hello, my dear JEE warriors. Welcome to the previous year question paper solving chapter wise for all the JEE mains 2024 questions, both January as well as the April attempt. And today we are going to do magnetic effects of current as well as the sources like the Biot-Savart's law, Ampere's law, Lorentz force, and all the other questions, magnetic moment, finding all these concepts, the questions which were asked in your JEE Mains 2024 examination. Okay, so let's begin with the class and mark your attendance quickly if you have not yet marked it, and let me know in the chat box, sir, I am present, I am here. Do let me know quickly. Yes, I hope I'm audible as well as visible to all of you. Okay, so let's begin with your captain Shreyas, sir. Quickly smash that like button in case you haven't marked your attendance yet, and also subscribe to the Vedantu JEE English channel. Also, let me remind you that as you are watching this particular video, all right, as you're starting to watch this particular video, you can find all the older videos right over here in the Jungle Book. You can see Jungle Book is a collection of all our videos as well as the PDFs as well as the DPPs. It's right over here. All the subjects arranged beautifully with the DPPs, the PDF notes, YouTube links, so that you do not miss any class and it is directly seen to you and very easily accessible. We will be adding more tabs in the near future. Okay, so do check that out. And in case you have not yet registered for the MVSAT examination, which is the scholarship test, absolutely free of cost. In fact, you will get more prizes. Just register right now. Very simple details. Register for it absolutely free. Offline tests have already begun. Online tests is yet to start, but you need to register for it. It's just a 1 hour test based on your current standard. Give it, get a lot of goodies as well as scholarships up to 100%. Not just that, you are going to get, lot of study material for your preparation of JEE just because you have attempted the test. So make sure you are participating and encourage the people around you to participate as well. Cool. So let's begin with the class. Ready for it, guys? Oh, hi Shalu. Welcome aboard. And if you're not liked it already, please like it. Okay, great. Chalo, let's begin with the session. Here comes the first question of MCQ on your screen. Here it is. Hi Hinada, Sarji, yes, welcome. Hi Lakshmi. Hi Arun. Here is the first question, guys. Let's try to solve this. A proton and a deuteron having same kinetic energy enter a region of magnetic field perpendicular to it. The ratio of the radius of the paths is how much? So whenever you have magnetic field perpendicular to the direction of the motion, then what it does is it performs uniform circular motion, and the radius is given by mv divided by charge into magnetic field. Mass into velocity is momentum. Momentum is root of 2 times mass times kinetic energy. The reason why I wrote it like this is because it is mentioned that their kinetic energies are same. So if kinetic energy is same, magnetic field is same, I can easily see the radius of the path is proportional to root of the mass and inversely proportional to the charge. So the radius of the deuterium upon radius of the proton will be root of mass of deuterium upon mass of proton, and here charge of proton on the top and charge of deuterium. So what will this become? Root of, it's clearly mentioned mass of neutron is 2 atomic units, whereas that of a proton is 1 atomic mass unit. So this will be 2:1. Neutron is basically 2 times the mass of the proton. Charge wise, it is just the same. So this is 1, this is 1. So hence the answer will be root of 2:1. Root 2 on the top, 1 over here. So root 2:1 is the correct answer. The challenge was to convert the velocity into kinetic energy. Seeing that kinetic energy is same, field is same, hence radius is proportional to root of mass and inversely proportional to the charge. Rest everything is given. Is that right? Fair enough. Shall we go to the next question, guys? All right. Here it comes, the next question on your screen. When currents change with time, Newton's third law is valid only if momentum is carried by electromagnetic field is taken into account. Ampere's law does not depend on Biot-Savart's law. Which are correct for the following statements? Yeah. Hiba, I think we will have to stop the PYQ series because I don't see that much of students seeing it. So guys, if you really want the series to continue, if you want us to solve all the things, because it takes a lot of time to remember, collect these questions, segregate it chapter wise, put it over here, and then solve these questions and then get it for you. So guys, I need your support for this series to continue, or else we'll just continue with the roar series and probably we'll do the chapters really quick. So need your massive support, not just in terms of views, but also likes and the comments, or else then I feel that I'm wasting time over here, right? So guys, need your support there. What do you think is the correct answer? When currents change with time, Newton's third law is valid if momentum is carried by electromagnetic field is taken into account. So what happens is when current changes, when current basically will either decrease or whether it will increase, then the magnetic field around it will increase or decrease. That will create an induced electric field around it that can change. So as a whole together, because the magnetic field is changing, electric field is changing, it will create an electromagnetic wave. And this electromagnetic wave also has nothing but momentum. You will see that any light particle has a momentum even in modern physics when you study photons. So technically speaking, this could have been asked after you study modern physics. But remember, any electromagnetic wave, be it X-ray, microwave, gamma rays, at the end of the day, they show dual nature, wave nature as well as particle nature. And when they hit, collide, or face some particle, it will have some momentum. So it definitely carries some momentum. The electromagnetic field definitely carries it. And whenever the momentum changes, obviously, if the momentum increases or decreases, what will that create? It will definitely create a force, and any force will have to follow Newton's third law. So there is nothing wrong in statement 1. There is definitely nothing wrong in statement 1. It is absolutely correct. Ampere's law does not depend on Biot-Savart's law. This is 100% wrong. Does not depend. It does depend. In fact, from Ampere's law, you can get Biot-Savart's law. From Biot-Savart's law, you can get Ampere's law. It's just like Coulomb's law and Gauss' law are not mutually exclusive. They are dependent on each other. If Gauss' law is invalid, even Coulomb's law is invalid. Same way, if Ampere's law is invalid, even Biot-Savart's law is invalid. So definitely this statement 2 is wrong. So 1 is true, 2 is false. Yes, that is what we were expecting it to be. Got it? It is not C. Yep, I hope this is clear. Yeah. Lakshmi, my name is Shreyas, Captain Shreyas. I just gave it to you right over here. Yes, you are Captain Shreyas, sir. Yep, cool. Shall we proceed with the next question coming up on your screen? Here it is. Start reading the question, guys. Start reading the question. So what happens is a long straight wire of some radius is carrying some current. It is distributed across the cross section. Ratio of the field at A/2 and 2A from the axis of the wire. So again, this is a standard kind of a arrangement. So this is your wire which is carrying some current, and maybe the radius of that particular wire is A. You have been asked two things: the magnetic field at this point at a distance of A/2 versus the magnetic field at a point outside which is at a distance of 2A. So when you are basically inside versus when you are outside, the formula of the field only changes. Outside, the formula is mu naught I by 2 pi distance. 2 pi into distance from the center. This distance is obviously given to be 2A. So therefore, it will be mu naught I by 2 pi into 2A, which will make it basically 4 pi A. So that is the magnetic field outside. But when you are inside, the magnetic field inside is given by mu naught I divided by 2 pi, the radius. Here you have the radius squared, and on the top you have basically the distance. The distance is nothing but a by 2. The radius is nothing but a. So what will happen is you will get mu naught I a by 2 and 2 pi. What is the radius? It is basically a. So a square. So 2 2s are 4. So a cancels. So mu naught I by 4 pi a. Don't you see they are exactly the same? So hence the ratio should be 1:1 because it just coincidentally comes out to be the same. Yes, that is the answer. C for Captain Shreyas. Is that clear, everyone? Where is Champa? Champa comes in the theory classes, maybe not in the problem solving classes. So whenever I have to give an example, definitely Champa will come. And Champa is also celebrating holiday today. Yeah, very rarely Champa gets holiday. All right. So let's get ready for the next question coming up on your screen. Here it is. There is some element which is placed at the origin carrying some current. Find the field at y-axis at this distance if the element's length is already given. Now, when you look at this question, this element carrying current will produce a magnetic field. So, finding the field due to an element, that is the application of nothing but our Biot-Savart's law. Biot-Savart's law. So, the magnetic field at any point, let's say that will be B, is given by mu naught I into that length, whatever that length is, dl, into sine theta, whole thing divided by, this is 4 pi, and then you have basically the distance, sorry, there is one more thing over here, that is the distance over here, I dl sine theta into distance, and you have distance cube over here. This is what the formula looks like. So now, if you start substituting the values, mu naught by 4 pi is 10 to the power minus 7. The current which is being carried is 10 amperes. The length of the element due to which you are trying to measure it is 1 centimeter, which means 10 to the power minus 2. The angle between the element and the distance, it's 90 degree. So theta is basically 90. So sine 90 is 1. This distance, one of it at least will cancel, and this cube will become basically 2. So what I will have is the distance square, which is nothing but 0.5 square. That's it, which is nothing but 0.5 square. I mean, there is nothing left over here. Yep. If you look at it, 0.5 is half. So half square is 1/4. 4 will go on the top. Everything is power of 10 or ones or 0 or decimal. So answer should be 4 into something. Yes, I don't even have to calculate. The answer will be, because this is half square is 1/4. 4 goes on the top. Whatever the powers are, I don't care. There is 4 only in one of the options. So directly I can say 4 into 10 to the power minus 8 Tesla. Did you understand this trick? Where I ignore the decimals, the zeros, the powers of 10, and if there is only 1 4 in the 4 options, that's it. I have no other thing to select or be confused. Hi Siva Kumar. Good evening. Good evening. Join in. Let's go to the next question coming up on your screen. The electric force and magnetic force on a charge moving with some velocity can be written as. So this question came really in the JEE mains exam, and many students were surprised thinking something is wrong. How can they ask such a simple question? But answer is, it is exactly what you expect it to be. Electric force is charge into electric field. Magnetic force is charge into velocity cross magnetic field. That is your Lorentz force if you combine it together. So it was just a question on Lorentz force. This was just a question on Lorentz force. Such an easy question came. This batch or whatever this shift was lucky for this question. Yeah, cool. Let's move on directly to the next question. Here comes the next question, guys, coming up on your screen. So we have coaxial straight cable. The central conductor and the outer conductor carry equal currents, but in opposite direction. The magnetic field is 0. Where do you think it is going to be 0? So just imagine this is the inside. Oops. This is basically your inside cable, and the outside cable is over here. This is your coaxial cable, something like this. Yep. This is your coaxial cable. I hope you are able to visualize this. So the currents are in the opposite direction, means wherever I can draw a Amperian path, closed path, such that the enclosed current is 0, then the field will be 0. Because that's what Ampere's loop law says. The dot product of the magnetic field, the dot product of that particular magnetic field gives me mu naught into the current which is enclosed. If I want the magnetic field to be 0, enclosed current should be basically 0. So there is only one such path which I can think of. How about I go like this? How about I go like this? If I go like this, what happens? If I go like this, the total enclosed current is 0. So naturally, the magnetic field will also be a big fat 0. So outside the cable is the correct answer. So I'm outside the cable. Everywhere the enclosed current will be 0. Is this absolutely clear, everyone? Can board students also watch? Ritvik? Yes, definitely. There should be no problem at all. Why should board students not watch? I mean, these concepts are there even in your NCRT. So outside the cable, yes, B for IIT Bombay. Very nice question on your Ampere's law application. Okay, Ampere's law application. Now this question says an electron is thrown with some speed along the axis of a current carrying long solenoid. So if you remember, for a solenoid, the magnetic field inside of it is basically along the length of the solenoid. That's how the magnetic field is. And you are throwing this charged particle in the same direction. You're throwing this charged particle in that, along that axis. So what will happen to the velocity cross the magnetic field? This answer obviously will be 0. Hence, the force acting on it will also be 0. Hence, the acceleration will be 0. Hence, the velocity will be a constant value. So, it will not accelerate, nor decelerate, nor change the direction. So, the electron will continue to move with uniform velocity along the axis of the solenoid, which is option D for IIT Delhi. Very straightforward question based on QV cross B concept. Nothing difficult at all. Very, very straightforward. Moving on to the next question. I hope you guys are enjoying the session and I hope you are appreciating the questions and how, solving these questions is probably building up that confidence. Sir, I thought JEE Mains was difficult, but actually if you think properly, it is not. If you target selectively, I'm going to complete this chapter now, I'm going to complete this chapter then, I'm going to complete this chapter after this week. And if you solve these PYQs, if you solve the class problems, solve examples, basic questions, no way you can get even 50 marks out of 100. You will definitely get 70 to 80 marks, in physics. There is no way you can get less marks. So guys, put in your 100%. Watch all the classes, watch a teacher solving the problems, then only you will understand. Just reading the solutions, no use. You have to practice these questions also. A uniform magnetic field acts along positive Y. A loop having this much current is in the YZ plane. The current is anti-clockwise with reference to the negative X. The magnitude and the direction of the torque is. Very interesting question. So first of all, let me show the axis. That will be better. So this is X. This is Y. This is probably Z axis. Okay. Uniform magnetic field is along the Y direction. Rectangular loop is in the YZ plane. Okay. In the Y and Z plane. So the loop is basically like this. Try to visualize this now. Yeah. It's in the YZ plane. And if you look at it, the current is anti-clockwise sense with reference to the negative x-axis. So negative x is behind. So if you look at it from behind, it is anti-clockwise. So if it is going to be anti-clockwise, so that means the current in this particular loop should go like this, should go like this, should go like this, should go like this. Because of that, the magnetic moment of this loop, just curl your fingers anti-clockwise for the negative x, it will definitely go behind. It will definitely go behind, guys. Just check this out. Yep, it will definitely have a magnetic moment backwards. And the magnetic field, of course, is given clearly. It is in the y direction. The magnetic field is in the y direction. So if you do m cross b, if you do m is there, cross b, I think it is going behind. So definitely the torque, which is going to be like this is your torque. This torque happens to be your m cross b. This torque happens to be your magnetic moment cross b, is along the negative z axis. So negative z is only there as option A. I won't even solve anything. That's it. I will directly mark it. But if there were two options with negative z, then I have no other option but to solve it. And we know how much is the magnetic moment. The magnetic moment is basically NIA. Remember, that's the formula, NIA. The number of turns, it's just a loop. So one turn. Current is 5 amperes and area is 20 means 0.2 meters and 10 centimeters means 0.1 meters. That is the magnetic moment. What about the magnetic field? This magnetic field is given to be how much? 2 into 10 to the power minus 3 Tesla. And lastly, the angle between them, guys, this cross product, the angle between B and M is 90 degree. So sine of 90, which is just going to be 1. So do the math, you will definitely get the torque magnitude as 2 into 10 to the power minus 4 Newton meter. That is what you're going to get. Is that clear? Directly you could tell it because I just looked into the direction part and it became very, very easy for me to understand. Please remember, in this problem, the person observing it was over here. The person observing it was on the negative side of the x-axis. This was z, this was of course y, and this was x. So this diagram was very important. Without diagram, you will suffer. So often I have been telling this, कि when it's a descriptive question, diagram is not given. First draw the diagram, visualize it, show everything that you know, see whatever you can find. Slowly you will build up the problem. Got it? All right. Let's go to the next question coming up on your screen. Here it is. And by the way, let me also tell you, there is an amazing surprise coming up. Some of you might have already heard about it, but I'm telling this to you because you are my students. Something really amazing is coming up for all the students of Karnataka. Be ready for it. There is a amazing channel which is coming up and you should definitely check out this particular video. All right, Vedantu Karnataka for KCT and boards. So all the Namma Karnataka students, do not forget to hit the subscribe button down over here, okay, for the Vedantu Karnataka channel. And there is also one more news, and that is for the Maharashtra students. Something really cool is coming up. So stay tuned, guys, for Maharashtra students, because MST CET is written by almost more than 6 lakh students. So Vedantu in Maharashtra, Vedantu for Karnataka. We already have Vedantu for Tamil students and Vedantu for Telugu students, for both Andhra and Telangana. So now it's time that we also move on to Vedantu in Maharashtra and Karnataka. Need your massive support. All the students over there should definitely go and check out the channels which are going to pop up. Yep. Cool? Yes. Let's move on. Let's go to the next question coming up on your screen. The wire which is having some semicircular path, the current goes in semicircle, wire comes out, magnetic field is coming towards you. The magnetic force is how much? See, there is one theorem which I have been telling you even when I told you the theory. The force on any curved wire, is the same as the force of an effective straight wire. of a straight wire. So what you do is, wherever the ends are, instead of that, you replace it with a single straight wire between the ends carrying the same current starting from here to here. So now the length of this, the effective length will be the diameter, will be nothing but the diameter, which is nothing but 2 times of the radius. So therefore that force will be current effective length into B into sine. Length is here, magnetic field is towards you, so the angle between them is 90 degree. So I into 2R into magnetic field, which is just B. So 2IRB, but which direction will it be? Well, length is here, magnetic field is towards you. Length is here, magnetic field is towards you. The thumb goes down. So if the thumb goes down, negative y-axis. So negative y-axis, so that means minus j cap. So you can see it very clearly. Length is over here and magnetic field is coming towards you. Magnetic field is coming towards you. So if you do L cross B, the force will come in the downward direction. Length cross B goes down. Okay? Or you can also do I cap cross K cap. I cross K is negative J. I cross K is negative J. As simple as that. Either ways you get it. Cool. Shall we go ahead to the next question, guys? All right. Let's go. Sivakumar, yes, for IIT exam, yes, the level 1, definitely it will be useful. Here comes the next question. 2 loops carrying current I in the anti-clockwise direction are shown. The magnitude of the magnetic field at the center will be how much? So, consider the 2 loops separately, individually. You will be able to get the answer easily. Due to this horizontal loop, which is carrying current like this, curl the fingers of your right hand. You will see the thumb going up like that. So, the magnetic field due to the horizontal loop carrying this current is in this particular direction. Now, curl your fingers along the vertical loop in this direction. You will see the finger going like this. So that means it should be in this particular direction. Both of them are mutually perpendicular. So naturally it means that the net magnetic field should be like this. This is your net magnetic field. And if each of them have same radius, same current, if each of them is basically B and B, so naturally my net magnetic field should be, because they are perpendicular, it will be B square plus B square, which is root 2 times of B. What is the magnetic field at the center of a coil? It is mu naught I by 2 times the radius. Radius is A. Root 2 cancels. So mu naught I by root 2 times of A. So mu naught I by root 2A is option number C, or third. Got it, everyone? Is that absolutely clear? Everybody with me? Awesome. Shall we move ahead to the next question coming up on your screen? Get ready for it. Here it comes. There are 2 particles and they are basically nothing but equal charges. Okay, and they are being accelerated through same voltage. Then they enter a region of field. Then they describe some radius. The mass ratio of x and y is how much? Okay, so this is how it goes. The radius of a particle in a magnetic field is given by mass times velocity divided by charge into magnetic field. Mass times velocity is momentum. Momentum is root of 2 times mass times kinetic energy. But the kinetic energy which it gains is nothing but the charge into the voltage difference by which it was accelerated. So Q cancels and I will be left with root of 2m delta V whole thing divided by Q, because root Q by root Q cancels and only one root Q remains, and what I am left with outside is just the magnetic field. So this is what the radius is in terms of the voltage, but clearly mentioned things are equal charges and same voltage difference, same voltage, same charge. So that means our radius is directly proportional to the root of mass. So radius 1 by radius 2 is root of m1 by m2, but the question is the mass ratio is how much. So m1 by m2 will be r1 by r2 whole square. r1 by r2 whole square is option D. Perfect. Got it, guys? Everybody with me on this? Is this absolutely clear? Is this absolutely clear? Very good. If you guys have got this, awesome, guys. Mainly, people get stuck over here to get till here. So first, mv is momentum. Momentum is root 2 times kinetic energy. Kinetic energy comes from electrical energy. Electrical energy is charge into voltage difference. So that charge into voltage difference gives me the kinetic energy which it gains. Okay, this is a standard formula which you should know. Moving on, a proton goes with a constant speed, passes through a region without any change in its velocity. E and B represent electric field and magnetic field, and the region might represent. Guys, this is a question based on cross field. If you remember this concept, when there is electric field also, and then there is maybe electric field is here, V cross V. Okay, so magnetic field is like this and the velocity is like this, such that it is E by B, then the net force on it is 0 and the velocity is basically constant. This is basically called as cross field, also used in velocity selector. I have told you about it. So magnetic force and electric force cancel out each other, which ends up in no net force. So electric field is there, magnetic field is there, yet the speed is constant. So the question is on may. May means possibility. Read the question carefully. May have. So it is like possibility. Which all things are possible? So obviously electric field and magnetic field both are non-zero. That is definitely possible. That is definitely possible. So, you know, I can immediately tick mark. This electric field is not zero, magnetic field is not zero. What about this? This is also possible. If this is the case, then what will happen? Think about it. No electric field, no magnetic field, no force only. If there is no force, obviously velocity will be a constant. But whenever there is electric field, 100% it will accelerate, assuming no magnetic field is there. So this won't be possible, guys. No matter what you do, the moment there is some electric field, that charged particle will have some acceleration, which means velocity won't be a constant. So C option can't be true at all. The only other option left is this. Imagine magnetic field is there, but the velocity is parallel to it. So V cross B will be 0 and the force will be 0 and velocity will be a constant. So it is possible. So even B is possible. So A, B, D. A, B, D, Willis. Okay. C option is the correct one. C for cap 2. I'm so glad, Ken, you saw me in V Buddy, and I hope you enjoyed those classes too. I've covered the entire syllabus of 11th and 12th for all the students who are in Vedantu right now. Entire syllabus taught by your Captain Shreyas sir. Is that right? So you can watch those classes. The portions, when will it be completed? Abhinesh will try to cover as much as possible by October. Whatever is remaining, we'll try to do it as one-shots, revisions, etc. later on. Okay? Chalo, let's move to the next question. Wow, we have come to the numerical part. Get ready for it. There is a magnetic strip having some magnetic moment. It is bent into a semicircular shape. The magnetic moment will be how much? So there is a magnetic strip, basically something like this. So that means there is north pole here, south pole here, and the magnetic moment will be nothing but the pole strength, let's say it is Qm, into the length of the magnet. into the length of the magnet. But the moment you bend it like this, this is north, this is south, it is as good as saying you have a new magnet. You have a new magnet where this is your north, this is obviously your south, and the new length L prime is basically 2 times of R. So the new magnetic moment M prime will be that same charge but into that new length, which is nothing but 2 times of R, which is nothing but 2 times of R. But wait a minute, this length and this length are the same, and the length of this semicircle, the length of this semicircle is nothing but just pi r, is nothing but just pi r. 2 pi r is circumference, semicircle's perimeter is pi r. So this pi r, shouldn't it be exactly equal to the length of this, because it was just bent into this shape. Oh, so from this what do I get? From this what do I get? Therefore r is nothing but L divided by pi. R is nothing but L divided by pi. So just substitute it over here. So QM2, and then you have L divided by pi. So therefore M prime will be, you have 2 divided by pi and you have QM into L. If you think carefully, this QM into L is the old magnetic moment, is nothing but our old magnetic moment, guys. That's it. So 2 by pi, and our old magnetic moment was 44. This pi, I can write it as 22 by 7. So 7 goes on the top. This goes with this 2 times. 2 2s are 4. 4 into 7, 28. Just check this out, 28. Yes, that is the correct answer. So the answer is 28 units. Is that amazing? Yes, the tablet pen experience is very different. Yeah. Video on how to increase attention span for hours. All right, JEE. Okay. So these kind of questions are very, very common, where you have some wire, it is bent into some L shape, semicircular shape, or some triangular shape, whatever. Main thing what happens is the effective distance between the North Pole and the South Pole changes. So because this length changes, the magnetic moment changes. So all you need to do is see what is the effective distance between North Pole and South Pole. Obviously, when you bend it, the effective distance would have changed. So you just find that new distance using simple geometry. The geometry involved here was the length of the strip is the circumference of the semicircle. So this length was pi r. From that you got the radius. From that you can easily get the new moment. Okay, moving on. Here is the next question, guys, coming up on your screen, where you have, there is a loop of 2 meters length, edge. It's a square loop carrying some current parallel to the XY axis. Okay, magnetic field is passing through the XY plane and expressed as this. So it's in the K cap, that means Z direction. B0 is 5 Tesla. The net magnetic force by the loop is how much? Okay, let's try to draw that particular diagram. All right. So this is my x-axis, this is my y-axis, and that loop is placed here. Square loop of the is placed with its edges parallel to the xy axis. Okay, this is our square loop. Remember, the length is already mentioned. This is 2 meters. That is also 2 meters. A magnetic field is passing through the xy plane expressed as this. So you can see the magnetic field is increasing with the x-axis. It is towards you because that's where the z-axis is. So here there might be some magnetic field. As you go over here, the magnetic field obviously is increasing. As you reach over here, the magnetic field will even increase further. Here it is less, here it is increasing. So if you ask me how much is the magnetic field on the left side of the loop, well, it will be, So the magnetic field on the left side of the loop. Here x coordinate is 0, so x is 0, it will be just equal to B naught. Whereas if you ask me over here, magnetic field on the right side of the loop, x will be 2 meters, 2 into 4, 8, 8 plus 1, 9. So it will be basically 9 times of B naught. If you consider this wire, which is carrying some current, okay, which is basically carrying some current, okay, this is current which is 2 amperes like this, which is like this, say for example. Length is here, magnetic field is towards you, length cross B goes like that. So the force on this side will be here. Whereas on this part, length is below, magnetic field is towards you. So the force will be obviously this way. This is the force on the left side. This is the force on the right side. You might wonder, what about this and this? Whatever it is, they will just end up cancelling. So I don't even bother showing them. But still, for your reference, I'm showing it over here. They will end up cancelling perfectly because this side same. Fields are also same. But here and here, the fields are not same. So from this, I can see that the net force will be the difference of the forces, left side minus right side, or in this case, right will be more. What is the force on the right hand side? I, which is I only, length, which is the side length, into magnetic field, which is 9 B naught, minus. On the left hand side, current is I, length is L, magnetic field is just B naught. So 9 minus 1 is 8. So 8 I L B naught. So substitute everything. Current is 2 amperes, length is 2 meters, B naught is basically 5 Tesla. Right? Is that right? Okay. 5 2s are 10, 8 2s are 16. So 160. That should be the answer. Yes, 160 Newton. 160 Newton is the correct answer. Did you get it, guys? Did you love this question? Yes or no? Quickly tell me in the chat box. Karthik Rahul, depends where you are talking about. Syllabus is finished. If you are talking about the VBuddy, my lectures are already available. Yes, it is over. If you are talking about my previous Pathfinder Nurture series, yes, the syllabus is done. If you are talking about the Road series, I am still doing the syllabus. Alright, if you are talking about some pro batches, well, the syllabus is still going on over there. Alright, if you are talking about crash course, well, it's yet about to come. Okay, cool. Let's go ahead. Hi, spread right. Shall we go to the next question? Did you love it? Now, here is this question. Now, guess what? The same question got repeated, but with different values. Similar things, slightly different things in the same year. Look at this. 0.2 1 plus 2x. Very similar to the previous one. Something 1 plus 4x. Magnetic field is there, current is there, edge is there. Find the net force exerted on it. So guys, I'm not going to redo the same question, but just the values are different. So think of how we did it over here and try to do this particular question. So this is like your homework question. This is like your homework question. Try this out on your own. You will get that confidence. Will you be able to do it? Yes or no? Quickly smash that like button. Let me know. Yes, sir, we'll be able to do it. The answer is, by the way, 50. I'm showing you the answer, but try to do it on your own now. Moving on to the next question. An electron with some energy enters a region of magnetic field in the perpendicular direction. Electric field is applied perpendicular to the velocity and magnetic field. The value of the field so that the electron goes in the same path. If you see in the match the following just now we did, if the speed remains constant, no force is there. This can only happen when magnetic field, velocity and electric field are mutually perpendicular and the speed equals electric field by magnetic field. That's all. The speed equals electric field by your magnetic field. So that's it, guys. That's all we have to do over here. So our speed should be electric field by our magnetic field. Electric field has to be found. Magnetic field is already given. Energy of the electron is given. So electric field is V into B. But we also know but we also know if I have an electron of this much electron volt, then how to find its kinetic energy? Kinetic energy is nothing but half mv square. So kinetic energy is nothing but 5 electron volt. So 5e over here, 1 by 2 m into v square. So v square is going to be 2 with 5, 10. So 10e by m. So that is v square. So v will be just the root of that. V will be just the root of that. So substitute this speed over here, which is root of 10 times of electron charge by mass, and then multiplied with the magnetic field. What you get is the electric field. So substitute everything, guys, whatever you know in this. All right. So electron charge is 1.6 10 to the power minus 19. Mass of the electron is 9 into 10 to the power minus 31. Magnetic field 3 micro Tesla, so 3 into 10 to the power minus 6. Solve this, you will definitely get the electric field in this scenario. From what I can see, 16 is there, 9 is there, so it will be a perfect square like thing. 16's root will be 4, 9's root will be 3, 3 and 3 will cancel, so 16's root, which is 4, will remain on the top. So the answer will be 4 something. Yes, I don't even have to break my head, it will be 4 something, unless, you know, the numeric answer can be anywhere from 1 to 1000. Then it can be 40 also, 400 also. If it is 1 to 10, I know the answer will be 4. So I'll just put 4 over here. Did you understand how we did this? Without actually having to calculate it. Because I ignored the powers of 10. Just look at the main numeric values. 16, 9 and 3. And 16 and 9 were obviously under the root. Deliberately they were given in that way. Is that right? Let's go ahead to the next question on your screen. Some coil, some area, some current in a field such that the plane of the coil is perpendicular to the field, the work done in turning the coil through 90 degrees. So, uniform field such that the plane of the coil is perpendicular to the magnetic field. So, this is our coil and this is the magnetic field. So, this coil carrying current will have its own magnetic moment. So if you turn it by 90 degrees, if you basically turn it by 90 degrees, something like that. So in this situation, you basically change the potential energy of it. So if you talk about this potential energy, initially, if you talk about this potential energy in the first scenario, it is nothing but mb cos 90 with a negative sign. Cos 90 is 0, so this is 0. If you talk about the second energy, it will be minus mb cos 180. Cos 180 is basically negative 1, minus minus makes it plus. So therefore, if you have to calculate the work is delta U. So it will be just mb minus 0, this minus this, which is just going to make it mb. Magnetic moment. How much is the magnetic moment of a coil? Number of turns into current into area. What about the magnetic field? Well, that is already given to me. So start substituting all the values. Number of turns 100, current 1 milliampere, so 10 to the power minus 3. Area of cross section 5 into 10 to the power minus 3. And the magnetic field is basically how much? 0.2 Tesla. Guys, 2 5s are 10, so the answer will be 10 something, power of 10. So yes, 100. So that feels correct. It should be correct. It should be some power of 10 only. It comes out as just 100 joules. So that is the amount of energy which is required. Actually, it is in micro. So basically 100 into 10 to the power minus 6 joules. So it will be 100 micro joules. Is that okay, guys? Shall we go to the next question? Yep, everybody with me? Okay, let's go to the next question. Same type of question I can see again repeated. Okay. Initially, the moment was in the field direction. The amount of work required to 90 degrees from the orientation initially is how much? Don't you see? Again, the same repeat concepts are there even in the same year. So guys, I want all of you to do this question as homework. It's the same repetition. That's why I put them side by side for all of you. Whatever you did in this question, it's very, very similar. You just have to find initial and final energies, find a difference to get the work done. By the way, the answer for this comes out as 5 microjoules. Very, very similar question. All right. Moving on to the next question on your screen. Read this question on basically solenoid. Okay, on a solenoid. This says that there is a solenoid of certain length, certain radius, certain number of turns, okay, carries some current, magnitude of the field inside is this much. What is the value of M? Straightforward question, nothing tricky about this. It is just mu naught Ni. Just you need to remember this is nothing but the number of turns per unit length. In this case, the turns is given to be M, length is given to be L, this is current. So magnetic field is how much? 6.28 10 to the power minus 3. Mu naught is 4 pi into 10 to the power minus 7. M don't know. Length 0.5. Current, how much is it? 5 amperes. So clearly you can see over here this 5 and this 5 cancels. 0.1 is there. So this decimal also goes. This will become minus 6. 4 pi, you can write it as 2 into 6.28 because 2 pi is 6.28. Pi is 3.14. 3.14 into 2 is 6.28, which is 2 pi. Bring that 2 here. So 6.28 and 6.28 will cancel right over here. And I just have 10 to the power minus 3 is 2 into 10 to the power minus 6 into basically M. So M will be basically, so 2 goes on the other side, becomes 0.5, 10 to the power minus 3, and we have 10 to the power minus 6 over here. So 0.5 into 10 to the power 3 over here, minus 3 cancels, negative 3 here is as power positive 3 on the top. So which is nothing but 500. So 500, yes, that is the correct answer. Okay, everyone. So simple calculations, the values are also given in a nice way. 6.28 is 2 pi, that's what you should have realized. Is that right? Cool. Let's go to the next question on your screen. Okay, this was done. Let's go to the next question, guys. So what do we have? A 2 amperes current carrying straight metal wire of some resistance, resistivity, cross section, mass given horizontally mid-air by uniform field. The magnitude of the field is given by. Okay, I'll tell you what it is. See, you have basically taken a wire and that wire is basically carrying some current. That current is basically 2 amperes. Now, if the weight of this wire is going to be downwards, which is mg, I want the ILB force to be upwards so that it remains suspended, means the net force on it should be 0. The net force on it should be 0. So this balances this, that's all. So basically ILB is equal to mg. And the question is to find B. Therefore, B is equal to mg by IL. Now, is the mass given? Yes, somewhere it is given. 500 grams, definitely. So it is 0.5 kg. Is G given? It is 10. Is current given? Yes, it is basically 2 amperes. Is the length of the wire given? Now that is what is not given. Don't worry about it. Resistivity, resistance, everything is given. We know the resistance is rho L by A. Therefore, think about it. Length will be resistance into area by resistivity. So that's it. So whatever this length is there, just substitute it as RA by rho. Resistance is nothing but 1 ohm. Area of cross section is 10 millimeter square. So 10 into 10 to the power minus 3 minus 6. Okay. Whole thing divided by resistivity. So resistivity will go on the top. Resistivity is 2 into 10 to the power minus 6. That's it. That will eventually give me the value of the magnetic field, which comes out as 5 into 10 to the power minus 1. 5 into 10 to the power minus 1. Actually, you can see that also 2 cancels, only 5 is remaining. So the answer will be 5 into something. Yeah. Is that clear, my dear students? Yeah, 10 also cancels, so only 0.5 will be remaining. Very, very simple question. Just ILB balancing mg, that's all. ILB was balancing mg, nothing else. Moving on, next question coming up on your screen. Two long wires carrying currents in the opposite directions separated by some distance. The magnetic field at the point midway is how much? Okay. Due to this current, curl your fingers. The fingers go inside. So 100%. Due to this current, the magnetic field is inside the plane. I'm just checking whether they cancel or they add. Due to this current, curl your fingers. Again, it is going inside only. So fair enough. The answer is at least not 0. But since the distances are same, it becomes easy for me to solve. The net magnetic field is nothing but 2 times the magnetic field due to any one of the wire. So you find any one thing, it is the same thing, same current, same distance, it's the midpoint. So the magnetic field due to a long wire carrying current is mu naught I by 2 pi r. So mu 2 cancels, so you just have mu naught by pi, current by r. Mu naught is 4 pi 10 to the power minus 7. This pi is as it is. Current 10 amperes. R, what is this distance going to be? This is basically your R, guys. 5 centimeters. So R will be basically 2.5 centimeters. It's exactly midpoint. So basically 2.5 10 to the power minus 2. That is what it is. Pi cancels, 2.5 is there, which is basically 10 by 4. So 4 goes on the top, something 16 will be there. Yes, so 160. So power of 10 will be there, but 1600% has to be there. So the answer comes out as 160 into 10 to the power minus 6 Tesla, which is 106 micro Tesla. Sorry, 160 micro Tesla. Okay, cool, guys. Straightforward question. Straightforward question. Loving these questions already. If you are loving it, make sure you are smashing the like button. Don't yeah, just be selfish and just watch the session for the sake of it, and yeah, go without liking. Then that is like not giving Guru Dakshina, and then you will never get that knowledge which you gained from this lecture. All right, moving on to the next question. There are 2 long wires parallel, separated by some distance. Ratio of the field at A to the magnetic field produced at C, I and 2I. Very similar to the previous one, it's just the currents are different, the positions are different. Other than that, nothing else. So if you talk about this current, hold the thumb like this. The field will go like this from behind and come towards you. So over here, the magnetic field is towards you. If you go to point C, the magnetic field due to this current will go inside over here. So it will be like this. Then talking about this particular current, thumb is here, the magnetic field goes from behind and comes towards you. So again it is towards you over here, and holding the current like this, thumb upwards, fingers go inside, so the magnetic field is here. So basically they add their fields, nothing else. So due to this current, the field over here is given by mu naught, current is 2I, divided by 2 pi r, that's it. Due to this current, the field over here is given by mu naught, current by 2 pi r plus 2r, which is 3r, which is basically 3r. the magnetic field due to this current over here, the magnetic field due to this current over here is given by mu naught I divided by 2 pi. This distance is directly r. Due to this current over here, the field will be mu naught into current divided by 2 pi r plus 2r, which is going to be 3r. So just add them together, that's it. You will basically get magnetic field at point C. Add these two together, you will get magnetic field at point A. Divide both of them, I think you will get the ratio. The ratio is asked, that's it. Is this very, very clear? They have just asked what is the ratio of the magnetic field at A to magnetic field at C. What is that ratio? That is basically x by 7. You can find how much this x is now. It's not that difficult. Is the concept clear? Grace, you can see the lecture title, bacha. It's there right over here as you are watching this video. Yep, where is it? JEE means 2024 PYQs, magnetic effects on current and sources. Okay. And we have done that in the road series also just couple of days back. If you have missed that previous classes, you can check it out right over here. Magnetic effects on current and torque on a loop. This was one class, and before this was this class. So this is almost a 4-hour class, and this is again almost a 3 hours class. So 4 plus 3, 7 hours of quality content of pure theory, concepts and problems. Yeah. Generate the world. If you want this series to continue, I want more viewership, bacha. Very simple, I'll tell you. Something works on YouTube if you watch it. If you don't watch it, then I will feel that very few students need it. Then I will, why would I do something which very few students want? I would like to do something which everybody wants, right? Because then it will benefit more people. Because I have to put in a lot of effort. I don't mind doing it for few people also. But the thing is, you need to understand it takes a lot of energy. And when I see very few students, then I will be like, okay, maybe you're not interested in PYQs, maybe you just want theory. So I'll make that lecture. So if you want the series to happen and continue, I want all of you to talk about the series with your friends. Even if you watch it recorded, it's fine. I can see the, your comments, your likes after a week, and I will see, okay, maybe your guys are watching it recorded, fine with me. But watching, learning is very important. If you don't, then I will feel that maybe you are not interested. Okay, so moving on to the next question. So that answer was 5 basically. So this value of x that you get was nothing but 5. Cool. All right, let's move on to the next question coming up on your screen. There is a moving coil galvanometer, some turns, area, magnetic field, deflection. When this much current is passed, the torsional constant is how much? If you know the formula for moving coil galvanometer, it is just a cakewalk. The answer for that is current is basketball, which is NBA, but a basketball which was kicked, and when you kick it from below, that means denominator, and K for kick, and this is basically theta. Okay, so that's it. Oh, sorry, this is opposite, my bad. This is your current and this is your theta. So this is the formula, guys. Theta is basketball, NBA, like you have FIFA for football, NBA, or IPL is for cricket, Indian Premier League. So same way, NBA, right, for basketball, but some idiot did not know basketball has to be played with hands, not with foot. So that idiot kicked the basketball, and where you kick from below, so that means denominator. So that's how you remember this, nothing great. Therefore, the torsional constant is number of turns, field, area, current divided by the angle. Number of turns 100, magnetic field 10 to the power minus 2, area of cross section 2 into 10 to the power minus 4, current 10 milliamperes, so 10 into 10 to the power minus 3, whole thing divided by theta, it's in radians. Theta, where is it? 0.05 radian, yes, 0.05 radian. That's it, you will get the answer. That's it, you will get the answer. This is 5, right? So basically 0.5 is 1 by 2, so 2 2s are 4. So something of 4, yeah. So you'll get the answer as 4. Even without calculation, you can know that it will be 4 into something. Because this is like 0.5. 0.5 is 1 by 2. 2 goes on the top, multiplies with this 2. 2 2s are 4. Everything is decimals, zeros or powers of 10. So it doesn't matter. 4 into 10 to the power something. So comes out as 4 into 10 to the power minus 5 Newton meter, which is torque per radian. Yes, this is the torque per unit angle. That is your torsional constant K. That's it. That's the answer. Cool. So guys, be little bit quick in the calculation part. Use the tricks which I have been giving you. That's it. Yeah. Yeah. If you are solving the first 2 exercises of Tatva, and please solve the DPPs also, whatever you are getting, and attend the mock test. And yes, the PYQs, that is a good enough thing. But remember, solve more and more PYQs. Don't be satisfied with whatever PYQs are there. Try to solve even the newer PYQs, very old PYQs. Don't stop over there. But if you solve at least the bare minimum, first 2 exercises, solved examples, you will definitely get above 90, 91, 92. Even probably with some extra practice, even 94, 95 also. But I would suggest, as a safety precaution, please solve more PYQs, even some solved examples and DPPs. Is that okay? Yes, Neha Bokre, but I want you guys to talk about this channel and the series with your friends. Otherwise, if the series stops, then you will again be like, sir, why did you stop? Okay, moving on to the next question. Regular polygon bent by a wire, electric current flowing through the sides. The magnetic field at the center of the polygon is how much? Okay, so let's first of all draw a polygon. Okay, and let's just consider a single part of it like this. Let's also draw a perpendicular distance over here. Now we all know this angle as well as this angle, each of them will be 30 and 30 degrees, no doubt about it. It's an equilateral triangle. So if the side length is A, the height of the triangle, the height, which is also the distance, which I can also call it as R, this R will be, think about it, if this is A, even this is A, even this is A, equilateral triangle. So this R will be A cos 30, it will be needed for my calculations. So it will be A root 3 by 2. So I found out this distance of the center from the wire. I need these angles for the calculation. I will tell you why in a bit. Next important point, if there is some current flowing through it, the magnetic field due to one of the side is mu naught by 4 pi current by the distance sine alpha plus sine beta. In this case, it is sine 30 plus sine 30. That's it. Sine alpha. Alpha is the angle made by the end with the center, and beta is the angle made with the end with the center again. Both the ends have to be counted. So that's it, guys. Mu naught by 4 pi is 10 to the power minus 7. Current 4 pi root 3. Okay. Sine 30 is, each of them is half. So half plus half is basically 1. Each of them is basically half. So half plus half is 1. Divided by R. Now you might be wondering, what is R, sir? It is A root 3 by 2. But the side is not given. But it is clearly mentioned that the length of the wire is 4 pi. Since there are 6 sides, so 6 is equal to 4 pi into side, which means A will be equal to 6 by 4 pi, which is 3 by 2 pi. So substitute A as 3 by 2 pi over here. 3 by 2 pi over here. This is root 3 by 2. That is your R. That is basically your R. Is that correct? Yes. Your A is nothing but 6 by 4 pi. 6 by 4 is 3 by 2. So put A as 3 by 2 pi. Root 3 by 2 is as it is. Okay. Now you just have to write R as 3 root 3 by 4 pi. Now just substitute that R as 3 root 3 divided by 4 pi. 3 root 3 divided by 4 pi. So that is the magnetic field due to one side. That is the magnetic field due to one side. What you need to do, you have to find the magnetic field at the center, right? So the net magnetic field, because there will be 6 sides, so 6 into magnetic field due to any one side. Solve this, you will get the net magnetic field, which then comes out as basically 72, which is basically going to come out as some 72 into 10 to the power minus 7 Tesla. Is that okay, guys? Everybody? Is this absolutely clear? So length of the wire was given. From that I found the side length. From the side length, I found out what is the distance, and that distance was used to solve the problem. Cool? Yes? Shall we go ahead to the next question? Shall we go ahead to the next question? I think one small mistake I might have done, I feel. Length of the wire is 4 pi. Guys, so sorry. When I did this, I made a small silly mistake. I just realized. So sorry. Even this will be wrong. The length of the wire is 4 pi. So bad. So that is 6 times of A. So I was just wondering why 4 pi is not cancelling. Anyways, so A will be basically 4 pi by 6, which is 2 pi by 3. So now put 2 pi by 3 here. Yeah, now it kind of makes sense. This is root 3 by 2 is equal to R. So therefore R will be 2 cancels. Root 3 cancels. So this will become pi by root 3. Now it makes sense. Yes. So R is nothing but pi by root 3. Now you can see that pi cancels and you can get a nice little answer over here. Is that okay? Yeah, now it makes sense. 72. Yes, perfect. Clearo? Okay. I just got that doubt because pi and pi was not cancelling otherwise. Anyways, moving on to the next question on your screen. There is some electron moving through a field. Particular time velocity is this much. Force is this much. Is the charge, then what is the value of B naught? Oh my god. They asked this question? Really? The force is given by charge into V cross B. The force is 5E K cap. Charge is electron charge, so E. Velocity, what is the velocity? Velocity is 3I cap plus 5J cap cross producted with magnetic field, which is B naught I cap plus 2B naught J cap. Okay. E and E cancels. So I'm just left with 5K cap is 3I cap. Okay, 3I cap cross producted with B naught, I can take it as common, I cap plus 2J cap plus 5J cap cross producted with, again B naught as common, I cap plus 2J cap. That's it. So from this 5K cap will be I cross I is 0, I cross J is K, so 3 2s are 6, so 6 B naught K cap, J cross J 0, J cross I minus K, so 5 1s are 5, so minus 5 B naught K cap. 6 minus 5, yes, 6 minus 5 is 1, so it is just B naught K cap. So 5 K cap is B naught K cap, so B naught is basically going to be 5 units. Yes, that is the correct answer. Simple cross product. They are just testing your vector knowledge and whether you know this formula or not. Best part, electron got cancelled, and you also saw that when you multiply I cap with I cap or J cap with J cap, the answer is 0. Even this is 0. So that's why you had 0 terms over here. Is that okay? I cross J is K, J cross I is minus K. Beautiful question. Not very difficult at all. Moving on to the next question. Some charge, some speed in a magnetic field, force is. Again, direct application of F is equal to Q V cross B. What's the charge? What's the charge? The charge is 4 microcoulomb. So 4 into 10 to the power minus 6 into, what's the velocity? 4 into 10 to the power 6 along positive y, that means J cap, cross magnetic field 2 K cap. That's it. Okay. What is J cross K? I J K. J cross K is I cap. Okay. So answer should be in I cap. Perfect. Minus 6 plus 6 cancel. So I'm just left with 4 into 2. So 4 4s are 16. So this will be 32 I cap. So that should be the value of the force. Yes, that is the correct answer. Very straightforward, guys. You can see what is the level of the questions which is asked in most of the shifts in your JEE 2024. Moving on to the next one on your screen. Current is moving in a square loop. The field at the center of the loop is how much? This is such a standard question. You might have seen it so many number of times. If this current flowing in this particular loop is like this, and if you want to find the net magnetic field at the center, since there are 4 sides for that loop, you find the magnetic field due to any one side and multiply it by 4. That's it. That is your answer. How much is the magnetic field due to any one side? For that, you need few things, like what's the distance from the center? Let's just say it is R, and obviously you join the end points with the point where you are measuring the field to note down the angles. This angle and this angle, both are 45 degrees each. So the magnetic field at this point due to any one side is given by mu naught current divided by 4 pi distance, which is R, sine alpha, which is sine 45, plus sine beta, which is again sine 45. That's it. If you are wondering what R is, just think about it. What will be R? This R will be the side length. This R will be nothing but the side length divided by 2. Obviously, sine 45 is 1 by root 2. This is also 1 by root 2. This 4 cancels. 1 by root 2 becomes 2 by root 2. And you know, all the other things, you can do the math and I think you will get the answer as 40. Okay, it's not very difficult. The final answer for our magnetic field at the center will come out as 40 root 2 into 10 to the power minus 7 Tesla. So our value which was needed was 40. That is what you will get. Not very difficult. Current is also given. If you are wondering where the current is given, well, it is given right over here. Current is 5 amperes. So this is 5 amperes, guys. If you are wondering what is the side length, well, even the side length is given. Side length is 1 meter. So this is 1 by 2. This is 1 meter. It's clearly given over there. So substitute everything, guys, you will get the answer. Is that okay? Cool. Very straightforward. This is a very common question, finding the magnetic field due to the square loop. In fact, we have done this even in the class so many times. Okay, next question, guys. The magnetic field at the center of a wire loop by 2 semicircular wires of different radius, R1 and R2, carrying current I, is how much? Well, if you talk about this semicircular loop, current is going like this, field will be inside, and this magnetic field due to this particular wire, let's say I call it B1, is mu naught current by 2R but multiplied by half. Why this half has come? Because it is not a complete loop, it's a semi-circle. So the contribution will be exactly half of a circle. That's why that 2 has come. Mu naught is 4 pi 10 to the power minus 7. 2 2s are 4. The radius is already given. What is the radius? R2. It is 4 pi. So 4 pi. And what's the current given like? The current is also given like 4 amperes. So that would be your B1. Same thing, do the calculation for this semicircular loop. Current is going like this. So the magnetic field will be inside again. So the magnetic field, oh sorry, this will be B1 guys, and this would be B2. So sorry, I gave the numbering wrong. Magnetic field due to this loop, since the radius is R2, it should be B2. The smaller loop, radius is R1, so the field should be B1. So mu naught by 2R current, but again multiply by half because it's a semi-circle. So the contribution will be half of the complete circle. So this will be half of the complete circle. So that's why that number is very important. Mu naught is 4 pi 10 to the power minus 7. Current is 4 ampere divided by 2 2s are 4. Radius 1 is nothing but 2 pi. That's it. You got the value of B1. But the question says find the magnetic field at the center. So the magnetic field at point O will be simply whatever B2 you found, whatever B1 you found, add them together, you will get the total magnetic field at point O. Just add this with this. Just add this with this, that's it. Say how much each of these values are. 4 4 cancels, 4 pi cancels. This is just 10 to the power minus 7. This also 4 4 cancels. This is 2 into 10 to the power minus 7. You can see that. 4 pi, 2 pi, 2. 4 4 cancels. So 2 into 10 to the power minus 7 is B1. So 2 into 10 to the power minus 7. Then this guy. 4 4 4 pi 10 to the power minus 7 as it is. So hence the total magnetic field 2 plus 1 is 3. So 3 into 10 to the power minus 7 Tesla. So the value of alpha which should be 3. Yes, that is the correct answer. Perfect. We got it. Cool. So these kind of questions again very common, and we have reached the end of the class. If you want to solve more PYQs of the previous years, we can courier the books for you, which is the previous year question papers. Complete package, no shift missed, no question missed, all solutions in a detailed manner. Okay, it's not just answer key, but even the solutions are there, and this will be couriered as hard copy, and I feel you should use hard copies also, or else it will be a strain on your eyes. Your eyes are constantly, watching some TV, computer screen, mobile. So if you want that, definitely you can order it right from over here in the description box, right from the Vedantu store. Okay, so you can just go down below over here and you can see PYQs right over here. You can order this, the latest edition for 2024, the last 2 years papers. You can also have a look at Advanced Rank Accelerator books, which is for JEE Advanced, exclusive material, new questions. This is not found on the internet. If you want the Tatva, which is like a complete package with the theory, concepts, summary points, notes, video snippets by scanning QR code, solutions, exercise 1, 2, 3, 4, graded exercise with PYQs, with mains and advanced concepts and questions. That's the book you should be looking for. If you just want the previous year mains questions, this is the book you should look for. All of this is right over here. Okay, you have a lot of other things too on the Vedantu store. You can definitely explore it, and whatever you feel like, please make the best use of it, because we are giving you all the resources. It's just about, are you using it or not? Okay, so thank you guys so much. Glad you enjoyed this class. smash the like button quickly, subscribe to the Vedantu JEE English channel, let your friends know if you want the series to survive. Okay? See you in the next class. Have a great time. Captain Shreyas signing off. Hasta la vista.